Let's talk about the Bainbridge Mass Spectrometer and the determination of isotopic masses of nuclei. Here is the index of a Bainbridge Mass Spectrometer. So the Bainbridge Mass Spectrometer is an experiment used for the accurate determination of atomic masses. So here is the atomic mass of carbon atom. It's 12. So calculating your protons and neutrons, summing up, you will be getting the atomic mass as 12. So this is how we will be using your Bainbridge Mass Spectrometer to identify the atomic masses. So atoms with one or more electrons removed becomes a net positive charge, and they become a positive ion. A beam of positive ion is produced in a discharge tube is culminated into a fine beam by two narrow splits S1 and S2. The fine beam enters into a velocity selector. The velocity selector allows the ions of a particular velocity to come out of it by the combined action of the electric field and also the magnetic field. The velocity selector consists of two planes P1 and P2, which produces a uniform electric field E and an electromagnet to produce a uniform magnetic field B, and this is represented by dots. These two fields are at right angles to each other and to the direction of the beam. So this is how the electric field and magnetic field is there. So this is how the fine beam is getting generated. You got your FB, the force due to the magnetic field and force due to the electric field. So its magnetic field is QVB and the electric field is QE. This is your undeflected particle. The electric and magnetic field are so adjusted that the deflection produced by one field is nullified by the other, so that the ions do not suffer any deflection within the velocity selector. Let E and B be the electrical field intensity and magnetic induction, and Q be the charge of the positive ion. You will be equating this one. The force exerted by the electrical field, which is QE, which is equal to the magnetic field BQV. So like striking out your Q, you will be getting V is equal to E divided by B, where B is the magnetic induction, E is the electric field intensity, Q is the charge of the positive ion, and V is the velocity of the positive ion. Only those ions having the velocity V pass out through the velocity selector and through the slit S3 to enter into the evacuated chamber D. These positive ions having the same velocity are subjected to another strong uniform magnetic field of induction B dash at right angles to the plane of the paper acting inwards. These ions are deflected along the circular path of radius r and strike the photographic plate. The force due to the magnetic field B dash QE, it provides the centripetal force. So B dash QV is equal to mv square, the force. So m is equal to, cancelling V and V here, you will be getting B dash Q into R divided by V. Over here V is equal to E divided by B indicates m is equal to B into B dash Q into R divided by E, where B is the magnetic induction and B dash is the uniform magnetic field of induction in the bottom, and E is the electric field intensity, Q is the charge, and R is the radius. Ions with different masses trace a semicircular path of different radii and produces dark lines on the plate. The distance between the opening of the chamber and the position of the dark line gives a value of 2r, from which r can be calculated. Since we know Q, B, B dash, E and R the mass of the positive ions, and hence isotopic masses can be easily calculated. Here is a picture of the Bainbridge mass spectrometer. This is how the Bainbridge mass spectrometer will be.